All right, here we're going to be looking at simplifying the radical expression. So when we want to simplify a radical, we want to use the property that this when we take like the square root of something squared, so like x squared, we get equal to just x. You know, if you imagine if you did the square root of 9, well, the square root of 9 is equal to, well, that's 3 squared. And so these square root kind of cancels out that radical there. So we just get 3 there. So when we want to simplify, we want to be looking for these perfect square numbers. So remember, these perfect square numbers are going to be, so if we're talking about n, and we're going to square that number, so we square 2, that's 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and 6 squared is 36, and so on. Okay, so when I'm looking at trying to simplify this number here, 72, I got to think that can be written as using one of these factors. So 72, the largest one that I can use is 36. Yes, it's divisible by 9 and it's divisible by 4, but I want to pick the largest one. So since it's divisible by 36, I know I can rewrite the square root of 72 as the square root of 36 times the square root of 2. The square root of 36 is 6, and then we just have square root of 2. There's no other factors over here that can go into that number 2, so then I know that it's in a simplified format. Okay, so notice that this index here of this square root is a 2 here. If it's not written, we assume it's there. So as we extend this and looking at simplifying radicals to the nth root, okay, let's utilize that principle. So first thing what I did over here, if you notice, is I made a table of my end of the fourth terms, because when I look at my index here of my radical at 4, I want to see what factors of 4 can I write in, or powers of 4 that I can write in, excuse me, that would simplify there. Okay, so when I have radicals and they have the same index, okay, I can multiply them together. So what I end up getting is, here is I get 8 times 8, so I get the fourth root of 64. Okay, so then I look over here in my table and I think, all right, which one of these goes into 64? Well, that's 16. So I can now write this as root 4, 16 times root 4. Well, 16 times 4 is 64. Okay, well, 16 is the same thing as 2 to the 4th. I know that because I've set up my table. And now if I do the fourth root of that, these like cancel each other out like our square roots does, and we just are left with the 2 there in front. This 4 has no more factors that are over here, so that just gets left inside our radical. And we're just left with 2 times 4 root 4. So here, looking at square root of 4, or the fourth root of 567, again, I'm looking for numbers over here that go into 567. So using my calculator, I divide it by 16. That doesn't work. When I divide it by 81, I see that 81 times 7 is 567. So if I write it like this, fourth root, okay, well, 81 can be written as 3 to the fourth root, and I have the fourth root, 7. So then these are going to cancel out here. So I'm just with the 3 gets kicked out, and I get 4 root of 7. Hope this helps clarify some of your questions on simplifying radical expressions.